So hi, my name is Vivek. In this video, let's take a look at this lead code question. So the number is 26 and the title is remove duplicate from sorted array. Okay, so I have already solved it. And the level for this question is easy. And let's see the acceptance rate. Acceptance rate is 53.9%. Okay, and the topic is going to be used is array and two pointers. Okay, so this is question related to the topic array and two pointer method or algorithm we can say. So let's just see the question. So let me just explain the question in the brief. So we have given a array of numbers. Okay, numbers. Okay, so what we have to do is simply whatever amount of whatever number of duplicate elements we have, we just have to remove or move that duplicate elements to the end of the array. Okay, and the unique elements was at the front. Okay, so that is what we have to do is simply in the example number two. Let me show you. The input array is this, in which we can see there are many of the elements which are repeating. Okay, so what we have to do is simply uh, whatever the unique elements we have, we just have to just push shift all of that unique elements at the front and duplicates element to the last. Okay, on the same array. Okay, we have to do all the operations on the same array. We don't have to create a new array. Okay, so now let's take a look at the constraints. So the constraints are the array length is going to be 1 to 3 into 10 to the power 4. Okay. And the array values is going to be from minus 100 to positive 100. Okay. And the nums is the sorted in non-decreasing order. This is the important point that the nums is sorted in the non-decreasing order. Okay. So we are going to solve this question with the two pointer method. So what we are going to do is simply one pointer is going to be this at the starting point, 0th index, and the second pointer is going to be at the first index. Okay, and we will compare both of them. If both are equal, then we just advance the geo pointer to the next element. If it is not equal, then what we will do, we will just increment this previous pointer and we will just uh, initialize the value with the next value. Okay, let me show you how I'm going to do is simply int I is equals to 0. This is our first pointer, which is going to point at the 0th index of the array. Okay, and I will just run a for loop and j equals to 1. This is my second pointer. Okay, this is going to be my second pointer. And this loop runs while j is less than array dot length in j plus plus. Okay, so this is I just applied the loop here. And what I'm going to do is simply I will check if array's ith element is not equal to array's jth element. If it is not equal, then what I will do simply advance the I plus plus means increase the point I previous pointer and just initialize the value at jth element to the ith element. Okay, so I have just whatever element I have on the jth point, jth pointer or index, I will assign that value to the ith index of the array. Okay, and if it is not equal, so simply the control flow goes to this j plus plus. I mean, it just increment in the j plus plus, and the loop will run again for j equals to 2. And this loop is going to be run again and again until array dot length. Okay, after coming out of this loop, we will just return I plus 1. Why I plus 1? Because this I is going to pointed on the last unique value we have just added here. Okay, so we have to return the size. So I is going to be index, so we will just plus 1 for getting the size. Okay, so let me run this. I will show you dry running it also. Okay, so all the test cases, sample test cases are passing successfully. So now let me just submit the questions. I mean, the submit the solution. Okay, so solution is successfully accepted. Now let's dry run this code for better clarity. So let me take this array as an example. I have just copied it. We will also discuss the time and space complexity for this algorithm. So let me open the multi-line comment. Okay, I just pasted. Okay, so my ith pointer, I is pointing here, okay, and J is pointing here. Okay, J is pointing here. So what I'm checking here is if both are not equal. See in this example, if not equal, then I will just increment in the I, and at the ith position, I will assign the jth element. Okay, so it is equal. So what we will do simply, okay, I'm sorry. So what I will do is simply increment the jth pointer. Okay, so I just increment the jth pointer. Okay, now I will check again if both of them are not equal. So yes, it is not equal. So what we will do is simply increment in this ith element and put the jth element, the ith element. Okay, so on the jth element, I have one. So I will just assign them to the ith index. Okay, and again j plus plus. So let's just increment in the jth pointer. We have just incremented the jth pointer. Now we will check once again if both of these are not equal, but these are equal. So will increment again. So loop will check again if both of these are not equal. No, these are again equal. So jth pointer is going to again increment. Okay, so j just increased, and we check again if ith and jth element are not equal. Yes, it is not equal this time. So what it is going to do is simply increment in the ith pointer, okay, and assign the value of jth pointer to the this pointer. And at the jth pointer, where I have to, so I just change that value and diet position with 2. Okay, now increment again in this jth pointer and check if both are not equal, but they are equal. So we will just increment again. This time, jth and ith element are not equal. So what we'll do, we will just update, I mean just increment in this ith variable. And at this point, we will just, what we'll do, whatever value is at the jth pointer, we will just reassign to the ith pointer. Okay. Then we will just again increment the jth pointer and check if both the values are not equal, but it is equal, then we'll just increment in the jth pointer, and we will check once again if both are not equal. Yes, it is not equal, then we will just increment the ith pointer, okay, and put the value at the ith pointer at the fourth pointer. Means whatever the element in the jth pointer, we'll just reassign it to the ith element. Okay, so j is now going to increment again. So it is out of bound now. So the loop will break. Now our ith pointer is now here. Okay, so after this, we don't have any unique values now. So what we will do here is returning I plus 1. So I is pointing at the what index? 0, 1, 2, 3, 4, fourth index, and the size is going to be 5. So I is 4 and we need 5. So that I'm just returning I plus 1. So I get the size. Okay, so this is the dry run of it. Now let's just discuss the time and space complexity. So time complexity is going to be, so we are just running the loop from 0th index to, I mean one index to the last of the array. So it is just linear. Okay, or we can say array dot length. It is depending on the array of. And the space complexity, what is going to be? Complexity. I think I spell it here wrong. Okay. And the space complexity, we are not using any kind of space. We can say we have just declared here I variable in j variable here, but it is only one time. Okay. So space complexity is constant. So O of 1. Okay, so this is the question, and here is the solution. I hope you understand. So this is all for this question.